In this example, we're going to look at fractions in context, and we're going to look at 4 different models. So there's many ways to think about fractions, and you need to be familiar with all of them so you can see how they connect to application problems and how you can use them in different ways mathematically. So first, we have the quotient model, or just division. So you can think of a fraction as just dividing the numerator, the top number, by the denominator, where the numerator is a dividend, the denominator is a divisor. And also, you can think of this as sharing equally into a number of groups, or fair sharing. The part-whole model, which you're probably familiar with, is you think of a part in the numerator and the whole in the denominator. So you won, say, 4 out of 5 games of something you played. Then there's a ratio part-to-part model. That's when you're comparing a part in the numerator and a different part in the denominator. So maybe you got 78 questions right on a test. You could say you got 78 out of 100, or you could say you got 78 correct, and that would mean you got 22 incorrect. So if we compared the number right to the number wrong, which are both parts of a whole, we're comparing 2 parts, that would be a part-to-part model. And finally, a rate model, and that's when you're comparing different types of units of measure in the numerator or denominator. So you could think of, one example is how fast you're going in miles per hour. You can think of your pay rate, that's how many dollars you get per hour. Okay, so let's look at these examples and write them as fractions. Get the highlighter ready. 3 cookies are shared among 6 friends. How many cookies does each friend get? Now, first we're asked to represent this as a fraction as opposed to division. Even though this is a division problem, you could think of this as 3 divided by 6. So you're dividing the 3 cookies into 6 equal pieces. Okay. And notice that that result is a fraction. It's less than 1. Okay. And not that all fractions are less than 1, but this one is. And to write it as a fraction, we put it as 3 over 6. Okay. And since it's a fair sharing problem, we would say that this is a quotient problem, or just a typical division problem. Okay. So any fraction, regardless of how it's represented, you can always do division to find a decimal approximation for it, which we'll learn later. So this is one way to think of a fraction. Let's look at the next one. 4 out of 6 people in the coffee shop have brown hair. And we're asked, what fraction of people in the coffee shop have brown hair? Okay. So notice we have 4 out of 6, and out of usually indicates a fraction situation. Okay, and when we're asked what fraction have brown hair, that means we want to find the number that have brown hair over the total number of people, in this case in the coffee shop. Okay, so notice this is going to be a part-to-whole situation. Our denominator is all the people in the coffee shop, which is 6, and we're looking at the part of that whole, the 4 out of those 6 people that have brown hair. So this we would write as 4 out of 6, and it's a part-whole model. Let's look at the next one. Tia won 6 games of heads or tails and lost 3 games of heads or tails. And we're asked, what is the ratio of games won to games lost? So we're comparing the same type of unit, whether she won the game or lost the game. Okay, and the whole in this case would be the total number of games played. So we're not comparing these two to the total number of games, we're comparing parts to parts. So since it says ratio of games won to games lost, that means we want the games won on top, which would be 6. Games won over the games lost, which would be 3. So this fraction, 6 over 3, represents the games won to games lost. And frequently when we have part-to-part situations, or sometimes even part-to-whole ratio situations, we use a colon to represent them. 6 games won to 3 games lost. Or you may hear in sports, their record is 6-3. They won 6 games and they lost 3 games. Okay, so this is the fraction representation, but this is other ways we sometimes represent it. And let's look at the last one. A snail travels 3 miles in 6 hours. What fraction of miles to hours does he travel? Whoops, that's the question. Let me make that green. And we're also asked, what fraction of hours to miles does he travel? So that probably almost sounds the same, but notice they're different. Okay, so when we're asked for the fraction of miles to hours, that means we want the miles on top and the hours on the bottom. And notice we have, in this case, it would be 3 over 6. And we've really made a new unit of measure, miles per hour. So you may know, it's okay if you don't, but 3/6 is the same as 1/2. So that means this snail is going 1/2 miles every hour. Okay. Now let's look at the fraction of hours to miles. So that would be 6 over 3 hours per mile. Okay. And notice that 6 over 3, if we think of this in terms of division, so we can move between these, and it's sometimes helpful, 6 divided by 3 is 2. So you could also interpret this as it takes a snail 2 hours to go 1 mile. So 2 hours to go 1 mile. And here we interpret it as 1/2 mile per 1 hour. Okay. So notice they're representing 2 different things, and there's 2 different ways we can interpret it. This is telling us the time to go a single mile. This is telling us the miles gone in a single hour. And both of those are examples of rates, because we're comparing 2 different units of measure. Also note this one was a ratio. That was right in the problem directions there, but we didn't write it.